All right, so this is going to be a video about the derivative of inverse function. So right here we have f of x as x to the fifth plus 2x minus 1. And it says over here we are looking for the derivative of its inverse. This f to the negative 1 right here is an unfortunate notation, meaning the inverse of this f of x right here with respect to x. And then you're going to plug in 2 to whatever that inverse is. All right, so to kind of start this problem off, I'm going to kind of rewrite how it looks just to kind of make it easier to solve, I guess for me anyway. All right, so first thing I'm going to do is I'm going to say that f of g of x is equal to x. Okay, so what I have in orange right here is basically the definition of an inverse function. And we are looking for the inverse derivative of f. So the inverse of f, and then we're taking the derivative of that. So we're basically looking for g prime. So g prime of x is going to be equal to 1 over f prime of g of x. And I made a previous video where it shows kind of where this equation comes from. Basically, we're going to be looking for this equation right here. We're going to be looking to solve this and then plug in 2. But if you notice, the heart of this equation is basically g of x. Now we are looking for g prime of 2, so I'm going to write that in really quick. G prime of 2, and replace all the x's with 2, so we're going to get 1 over f prime of g of 2. So I'm going to write that in there real quick like that. All right, so the heart of this one is going to be g of 2. Just like I said before, the other one was the heart of g of x. So we need to find what g of 2 is. So we're going to use this equation right here basically to figure out what g of 2 is. First thing I'm going to do is fill in this inverse definition really quick. So it's going to be f of g of 2 is equal to 2. And then from here, I'm going to be filling in this f of g of 2, this right here, with whatever our f of x is, which is right here. So I'm going to be using this equation in black right here, but I'm filling in the x with g of 2. All right, so now from here, we have this equation, and this one's actually pretty easy to solve because you can just use guess and check. So basically, g of 2 is going to be equal to 1, because if you put a 1 in here, it would be 1 to the fifth plus 2 times 1 minus 1 is equal to 2. So that kind of proves that g of 2 is equal to 1. Now, whenever you're given a problem like this, usually it's best to try to just do a little bit of guess and check, because if this was a non-calculator part of the test, that's the only way you'd really be able to figure this out. And when that happens, the answer is usually something pretty easy like this. All right, so we're not done yet. Now that we have g of 2, we can use this g prime of 2 equation right here and fill in what we know. So basically, g prime of 2 is going to be equal to 1 over f prime of 1. And we're going to take this 1 from g of 2 and basically fill it in here. That's what I just did, just some substitution. Now, it says 1 over f prime of 1 here, so we need to figure out what f prime is and then plug 1 in. So I'm going to do that right now. All right, so I have my f prime equation, and I'm just basically going to be filling in 1 for this equation to find that f prime of 1. So if you plug in 1 for that f prime equation, you get 7. So then from here, I'm just going to substitute it back in for this 1 over f prime of 1 equation to get my final answer. And that's basically how to find the derivative of an inverse function at a specific value.
All right, so real quick, I wanted to show what this looks like graphically. So as you can see right here in the red, I have that f of x function, the x to the fifth plus 2x minus 1, and it's graphed here. And then I graphed its inverse right here in green. So that's what we have right here, blinking in green. And it's kind of labeled here, inverse of f of x below, that's what this is. And if I use my derivative from previously, I kind of wrote that right here with this m, it's 1 over f prime of 1, you get 1/7, which is what I got. And then I use that to figure out my b, which is the y-intercept. And then if I graph this, this should graze the point on the inverse function here, right at 2, 1. And as you can see, it does, and that kind of proves that the derivative of that inverse is correct.
So if you have any questions about anything in this video, let me know.